Good morning, students. Okay, we have come to the last topic of this course, probability. So this morning we are going to look at probability. Now, probability measures the likelihood that something will occur. So actually, probability enables us to take decisions about uncertainty. So it's measured between 0 and 1, with the 0 and the 1 inclusive. Okay, so let's look at our objectives for today's lecture. So at the end of the session, you should be able to, one, understand the rules of probability, and then how to assign or determine probability for each possible outcome of an event. So here we'll look at some underlying terminologies. For example, what do we mean by sample space? If you understand these terminologies, then probability is very simple, right? So sample space, event, experiment, and so on, a trial. So look at them. Okay, so understand the concept of random variables and probability distribution. So we have two forms of variables, random and discrete. So random simply means that it behaves in an uncertain manner. So when you have a discrete variable that is countable, for example, if you are counting human beings, you cannot say 1, 1.5, 2.3. No. For if it is discrete, then it takes whole numbers, right? So if you are counting human beings, say 1, 2, 3, and so on. But when you are measuring your height, your weight, or time, you can see that we have fractional values assigned to those measurements, and those ones are what? Continuous variables. Okay, so look at them and then understand and calculate expectation. That is mathematical expectation, which is simply to multiply the expected value by its corresponding probability to get the expectation. Expectation simply means the average, what you are expecting. Okay, so mean or average, all right, of a random variable. And then understand and calculate standard deviation and coefficient of variation of a random variable. Of course, this enables us to um, take decisions, especially in the choice of two mutually exclusive projects. So the higher the coefficient of variation, the more riskier the project. Are you okay? So when you compare that, then you can select projects that are mutually exclusive. And then finally, we should understand the role of coefficient of variation in business. Okay, so that is what I've just explained. Okay, so like I said, probability actually measures the likelihood that something will occur, right? But we need to understand these terminologies. First, what do we mean by experiment? You see, anything that the outcome is not certain, you cannot determine the outcome with certainty. It's an experiment. For example, when you are experimenting in the lab, you don't know the outcome until the experiment is completed. And that's exactly what probability is. So when you are tossing, let's say, a coin, it's an experiment. And before the coin is tossed, you will know whether the coin will land on heads or on tails. In fact, for coins, we assign, because it has two faces, we assign one face as the head and the other face as the tail. So when the coins is tossed once, what will be the possible outcome? It may land on head, it may land on tail. Or when you throw a die, a Ludo die once, how many faces has a die? There are 6 faces. So you don't know whether 1 will appear, 2 will appear, 3 will appear, up to the 6. So that is what? An experiment. When you draw a card from a pack of 52 playing cards, it's also an experiment. You see, so the packs, the cards, they are all made up of 52. Okay, so when you are drawing just one card, that is an experiment you are performing. You don't know whether you draw a club, a diamond, or you draw an essay, you draw a king, you draw a queen, you draw a jack, and so on. But the cards are made up of four different types. We have the diamond, we have the heart, we have the club, and we have the spade. Now, in our local environment, we call the diamond Kalu, and that is just a name that has been assigned to it. We call the heart as yet, which is incorrect. We call the spade as spa, and then we call the club as kule. And so those are just local names that has been assigned, but the actual names is what I've just explained. Okay, so they are experiments. So any event that we don't know, the outcome cannot be determined with certainty. It's described as an experiment. Okay. Then we also have what we call an event. You see, an event is a subset of the experiment. But let me explain what we call random space first, because we need to know all the possible outcomes of an experiment. It's what we call random space. If you toss a coin has two faces. So what are the possible outcomes? There are two of them, head and tail. So the sample space for tossing a coin once is what? 2. There are two events that can occur. So either head or tail. Now, if you toss a Ludo die once, how many faces do we have? 1 up to 6. So the sample space is the numbers 1 to 6 for a single toss of a Ludo die. You see, if you are drawing a card from a pack of 52 playing cards, because the number of cards you are drawing from is 52, then the sample space is 52. All right. Now, when you toss 2 coins, you see now the coins are 2 and you toss it once. Let me show you how we use probability tree to illustrate that, how you draw the outcome for tossing of 2 coins. Okay, so let's say coin 1 is this line, right? And then coin 2 is this. So that's the first coin. Are you okay? So we label this as coin 1, and then this is okay. So normally we assign the probability of an event by PA. So if this is PA, okay, let me use the outcome for the coin to denote it, because that will be more simple. Just write the outcome. So it will land either head or tail. So the first coin, oh my goodness. So the first coin will land head. So that is T. Oh my goodness. Or either head or tail. Okay, so head. I don't know why the thing is not smooth. So head or tail. Okay, so and then we toss the second coin. So when we toss the second coin, it will also give us 2 possible outcomes from the first coin. So this will also land head. To land head or tail. And this will also land head or tail, like that. So how many possible oh sorry, I've written T for the head. So either head or tail. Okay. So here we see that the possible outcomes will be what? 4. Let me rub it. It's very difficult to write. So we'll have head. So here, if we follow, we're taking it from the scratch. So like you go through this direction, you see, we have 2H. So head. Then we go from here and then we come this way. So here we have what? Head, tail, head, tail. So HT. Then from here to this side we have what? Tail, head, tail, head. So tail, head. Then the last one we have tail, tail. Now take note that TH is not the same as HT, right? So TH means either the first coin will land head and the second, sorry, TH means either the first coin will land tail and the second will land head, or HT, which is the first coin will land head and the second will land tail. So when we toss two coins, then the set of possible outcomes will be, there will be four of them, right? So HH, HT, TH, then TT. Okay. Now, so these four outcomes will be the sample space. See, so each of these elements, HH, is an event of the sample space. HT is an event of a sample space, and so on. So let's look at when we toss three coins. See, when we toss three coins, and I'm doing this because I don't want to erase everything and start the whole thing again. So if it's about three coins, then just about extending what we have drawn, right? So three coins, then I'll extend it. So this represents two coins. So if it is three coins, then I'll have another head or tail for each branch. So head or tail. Then here too I have head or tail. Head or tail. You see? Then here too I have head or tail. The last one, head or tail. So head or tail. Okay. So if it's about three coins, then what will be the set of possible outcomes? You can see that we have three heads. So here, when we go from H, so we have three heads. So there will be 8 possible outcomes. So H, H, H. Then HHT. So H, H, T. Then HTH. So H, T, H. Then HTT. So H, HTT. And then THH. So TH. H. And then THT. So TH. T. And then TTH. So T. H. And then TTT. So the first HH simply means that when you toss a coin 3 times, in fact, tossing one single coin 3 times is the same as tossing 3 coins once. Take note. For example, if you have only 1 coin and you toss it 3 times, the sample space, that is a set of possible outcomes, will be the same as having 3 coins and tossing them once. So there will be 8 set of sample space. What about a die? Remember that when you have 2 or more die, we call it dice. D-I-C. If it is 1, it's a die, D-I-E. So when a die is also, you have 2 dice. We know that for a single die, there are 6 set of possible outcomes. The numbers 1, 2, 6. Now, what about if they are 2? If they are 2, then the set of possible outcomes will be 36. That is 6 by 6. If they are 3, then you have 216 as the total set of possible outcomes. So that will be the sample space for tossing 3 dice at a time. I mean once. Okay. So look at that one too. Because when you toss 2 dice, there is a possibility that the first die will show 1 and the second die will also show 1. There's a possibility that the first die will show 2 and the second die will show 1. There's a possibility that the first die will show 3 and the second die will show 1. See, up to 6. And that will give you 1 row. So let me just illustrate it briefly. Then we proceed. Okay, so this one, let me draw. We'll have about 36 of them. So I draw the lines. So these are 2, 1. So 2, 3, 4, 5, 6. Okay. So 6. Just to divide this into. Okay, so 1, 2, 3, 4. Okay, so 5. So if this is die 1, this is die 2 rather, die 2, so die 2, die 2, and this is die 1, die 1, D1 is die 1. So first, either the first die will show 1 and the second will also show 1, or the first will show 1 and the second will show 2, or the first will show 1 and the second will show 3. take note that the numbers I'm writing, they are not 11, 12, 13. It's the outcome for each die. So in actual fact, in representing them, because I'm finding difficult to write, that's why I'm writing. So by in actual fact, we should have introduced comma and then brackets, you see, like this. So there should be a comma here. Okay, so the first die will show 1. The second die will show 3 for this one. So the first die will show 1. The second die will show 4 for this one. The first die will show 1. The second die will show 5. And then the last one, the first die will show 1 and the second die will show 6. I don't see why this thing is. So the first die will show 1 and the second die will show 6. Or the first die will show 2 and the second die will show 1. The first die will show 2 and the second die will also show 2. Or the first die will show 2 and the second die will show 3. Or the first die will show 2 and the second die will show 4. Or the first will show 2 and the second 5. And so on. The first 2 and the second 6. Or the first die will show 3. You see? So it will continue like that up to, so here will be either the first die will show 6 and the second die will also show 6. So in all, if you count all the boxes, you get 36. So there will be 36 possible outcomes for a single toss of a die. All right. For a single toss of a dice, that is 2 dice. If it's only 1 die, then the outcomes will be only 6. Okay, so let's go back to our slide. So that is what we call sample space. That is a set of all possible outcomes for a single experiment. Now, what is an event? An event is a subset of the sample space. So if you toss a die, what is the event of an even number? There will be 3 even numbers, 2, 4, and 6, you see. So the event of even number for a single toss of a die are the 2, 4, and 6. The event of an odd number is also 3 of them, 1, 5, and 3. Or the event of an odd number is also 3, that is 2, 3, and 5, and so on. So when we toss 2 dice, the event of obtaining a number with the sum of 12, it's only 1, that is 6, 6. You see? Okay, so let's go on. We have now understood what we mean by experiment, what is meant by a sample space, and then what is meant by event. Now, we also have what we call trial. A trial is a single performance of an experiment. So if an experiment is performed several times, then we have several trials. You remember in court, we say, let's try the accused person, you see. So a single performance of an experiment is what we call a trial. Okay, so per our slide, we said that most times one would have to make a decision before observing the outcome. And that is the experiment, right? So for example, invest in a business today and attain profit or loss tomorrow. Plan electricity generation capacity today in anticipation of next year's demand, which is uncertain. Toss a coin, the result is uncertain and could be head or tail. There is some level of uncertainty surrounding the outcome of each of the examples above, right? So probability is just a tool that enables us to make decisions in an uncertainty environment. Now, the uncertainty makes the decision process challenging. So how can one make better decisions in such an uncertain environment, you see? And then this is done with the help of probabilities. So that is, so a probability gives a measure of uncertainty. That is, the probability of an event is a measure of its likelihood or chance of occurrence. Okay. Now, making decision under uncertainty. Statistical experiment. A statistical experiment can be described as any situation specifically set up or occurring naturally. So I've given you examples of an experiment. A statistical experiment have these things in common. The experiment can have more than one possible outcome. Yeah. Now, each possible outcome can be specified in advance. The outcome of an experiment depends on chance, tossing a dice. It should be a die, not dice. The possible outcomes could be 1, 2, 3, up to 6. So this is just one die. So it's not dice. If it's 2, that's what it says dice. Okay, so after the experiment is performed, only one of the possible outcomes will occur. All right, so these are all giving you what I've just explained. I'm just reading through for you to understand. And then we have what? Coin, head or tail. We have a die, which is also 1 up to 6. You can play a game, lottery, depending on the set of numbers, the sample space for lottery will be 1 to 90. That is if the numbers that are drawn is from 1 to 90. So you win or you lose and so on. Okay. Then events. I have explained that event is a subset of the sample space, right? So an event is any subset of a given outcome, and the given outcome is a sample space. So a given outcome set of an experiment that is of interest. Thus, after performing the experiment, the event may or may not occur. Now, let's take note that probability, you see, probability actually helps us to take decisions in an uncertainty environment. So we try to assign numbers to the event or the probability. And these numbers ranges from 0 to 1, with the 0 and the 1 inclusive. Now, if the event or the probability that the event may not occur, and then that is 0, for example, what is the probability of getting a boy in a girl's school? A boy student in a girl's school, that is not possible. So the probability will be 0. If the probability has 100% of occurrence, then that will be 1. For example, picking a red ball from a basket containing 10 red balls. You see, all the red balls in a basket, all the balls in a basket are red. And then you have to pick at random. Randomness means that you are just picking without looking into the basket. So that one too, you at all costs pick a red ball. You see, so that will be 1/1 and its thing. We'll come to how to calculate probability. So suppose the experiment in tossing a die, not a dice. So the outcome said to be 1 to 6. What are the chances that 2 or 3 might show up? So 2 or 3 are the event. Then we have some properties assigning to events. We have what we call mutually exclusive events. We have independent events. We have dependent events and so on. So here they said we should look for what we call mutually exclusive events. That is 2 events that they cannot both occur, right? Something that we can identify them exclusively or uniquely. That is, 2 events of the same experiment are mutually exclusive if their respective event sets do not overlap. Let me draw show you what we mean by mutually exclusive. So let me get my whiteboard screen. Okay, so let me erase this quickly. That will take some time, but I think we'll get it very soon. So if you have a non-intersecting set, you see, 2 sets that they do not intersect. So when we say they are mutually exclusive, it simply means that they have nothing in common. So the intersection aspect is 0. So I think I have space now. Okay, so let me just draw. Normally, in our set theory, we know that, oh, this one there, let me change. Normally, in our set theory, we know that the square gives us our Venn diagram, or that would be the, so if you have two events A, so this event A, and then we have another event B, you see, and they are not intersecting like this, then this is mutually exclusive. So here we say that A intersection B. I'm just writing the intersection sign. So A intersection B is equal to 0. It's not 0, it's now, sorry, now empty set. Because 0 is a numeral, it can represent. Okay, so let me go back to the slide. So go back to the slide. So that is mutually exclusive. So when the intersection is 0 or is now, sorry, independent set. Two events are independent if the outcome of one of the events in no way affects the outcome of the other. All right. And then we have dependent events as well. So independent events actually follows what we call the multiplication rule. So if the events are independent, we just multiply the two to give us the probability. Then we also have the addition rule, right? So normally in probability, when we use the word, the conjunction, right? English word conjunction, and, it means that we are to multiply. That is, the two events are independent. But then when we say or, then it's what? Addition. So you have to add the respective probabilities. Okay, so how do you measure probability? Now, we have what we call empirical probability, relative frequency. Well, we just measure probability by dividing the possible outcomes or the sample space. We divide the event, that is the number of ways in which the event can occur, over the total number of sample space. For example, the probability of scoring an even number for a single toss of a die, because there are 6 numbers on the die and there are 3 even numbers on the die, right, among the 6. That is 2, 4, and 6, right? Then the probability of, or the event of scoring an even number can occur 3 times. So that will give us 3 over 6. The probability of scoring an odd number for a single toss of a die will also be what? There are 3 odd numbers, that is 1, 3, and 5. And the set of possible outcomes are 6. So that will be what? 3 over 6, so that will be half. Remember that there is no probability that will be more than 1 or will be less than 0. If you are getting more than 1, you are wrong. You are incorrect. You should check. If it's less than 0, it's wrong. But you can get probability to be 0 and you can get it to be 1. That is, if the event is an impossible event to occur, then the probability will be 0. If the event is a sure event, 100%, you see, then that will be 1. Apart from that, all your probabilities will range between 1 and 0. Take note. So the definition of probability is simply number of ways or times that events can occur over the number of possible outcomes, as I've explained. If, for example, you have tossed 3 coins, then you should know that the sample space is going to be 8 sets. You have 3 heads